Here we go, guys. Let's do this.
Our group's theme is expansion by heat exerting pressure, and in this lab called the Magic Beaker, we'll show how heat and pressure can make a partial vacuum. For this lab, we need an empty jar, a lighter, and a piece of paper. So first we're going to light the piece of paper on fire. And once it's lit, drop it in the jar and immediately cover it with our hand.
Okay.
As you can see, it creates a partial vacuum. Now an explanation of the Magic Beaker lab. The only thing in this jar right now is air at room temperature. When Heather put a piece of burning paper into the jar, the air inside the jar began to heat up and expand. Now, when you put your hand over the jar, you're cutting out the flow of oxygen into the jar. The air inside the jar now is cooling and it begins to contract. Now the pressure inside this jar is smaller than the pressure outside of it, and that's what causes the partial vacuum.
In this demonstration, Galvin and I will be exploring the concept of expansion by heat. In front of us we have 3 boxes and 3 jars, and in each box is the same exact amount of water, so the only changed variable is the number of candles. Now Galvin and I will begin putting the jars over the candles. So now the only difference between these 3 scenarios is the amount of heat in each jar. So the jar with the highest water level was the jar with 3 candles, which means it had the highest temperature, which was the main factor causing the air to expand before the jar hit the water. And this is why this jar had the least air trapped underneath and therefore the lowest pressure, and that's why the water in this jar is the highest.
So in this lab, what we have is 1 candle, a box, and a jar, and a lighter. So what we're going to do first is Mavy's going to light the candle. And then she's going to put... she's going to light the candle. And then she's going to put the jar over it. A little explanation of what just happened. So the burning candle needs oxygen, and when the cup is placed over the candle, the flame goes out, therefore taking away all of the oxygen from under the cup. Because the space under the cup doesn't contain any more oxygen, it exerts less pressure compared to the atmospheric air. Then the water is pushed into the space under the cup, thus that. Alright.
So after watching all of those examples of expansion by heat and expansion by heat and pressure, you're probably wondering, when will I see any of those things in real life? Well, let me tell you, there are quite a few real-world applications. For example, the first one being that of the titanium fuselage of an American SR-71 Blackbird aircraft. The aircraft used to drip badly on the tarmac, but when they took off and flew at the cruising airspeed, air friction would heat up the fuselage, and the air would expand and tighten up, and the leaks would stop. Another example is the liquid in a thermometer. As the temperature outside increases, the liquid expands up the tube, indicating the higher temperature outside. My final example of expansion by heat in the real world is one that most everyone's experienced at least once in their life. If you leave a water bottle with a straw in a hot car, the air inside the bottle expands, pushing the water higher and higher up into the straw. So when you go to take a sip from the bottle, the water explodes everywhere.